talked about the two differences between the enhancement type and depletion type MOSFETs. The initial voltage is required to induce a channel, and the channel is already created. And MOS and PMOS. The channel induced on the silicon dioxide layer is N channel, and PMOS is if the channel induced down the silicon oxide layer is P channel. The gate and the channel region of the MOSFET forms the parallel plate capacitor with the oxide layer acting as a capacitor dielectric. The positive gate voltage causes a positive charge to accumulate on the top plate of the capacitor. The negative charge gets induced on the opposite plate of the capacitor. An electric field is developed in the vertical direction, and it is this field that controls the amount of charge in the channel. Therefore, it determines the channel conductivity on the current flow that flow through the channel when the voltage is applied between drain and source. Okay, please kindly make this sure that you understand this concept well, because understanding this concept will build the basic foundation for your further activities on MOSFET. Now, if we wish to know the characteristic of the MOSFET, on applying gate voltage in N-type channel, we have come across to the point that the channel starts developing when it crosses the threshold voltage. So at that time, the current starts flowing from drain to source. Source is grounded and drain is again positive charge. But eventually we will see that on applying VGS to a level, on more and more, when you are on applying VGS, the channel is created. Now we start applying positive voltage on the diode region. As the VDS increases, so does the current crossing the channel. As the current increases in that region till the point we reach that the VDS voltage is less than VGS minus VT voltage. VGS voltage, the already applied voltage, we have made this constant, minus the threshold voltage which was required to form this channel. Okay, till the point the VDS voltage is less than that voltage, it remains in triode region. Triode region is that region where the current is still increasing to a particular point, but the time the VDS increases beyond that voltage, the current saturates. The current saturates because a pinch of air has occurred at the drain region, which allows only a constant flow of current, constant flow of charge. Actually, that flow of charge becomes constant and only that current is maintained. On further increasing VDS, there is no additional value added to the constant current, and ID saturates. Thus, if you keep on increasing VDS, no further increase in the current you will see, and the current will remain constant at this value. So, from this particular graph, you can see that at the point VDS is equals to VGS minus VT, which is termed as VGS saturation, the current saturates because the channel is pinched off at the drain end. If you further increase the VDS voltage, it will make the channel shorten, and shortening the channel might disrupt the normal functioning of the MOSFET. So in that particular region, maybe you will get an unpredictable results. So there is no further use of increasing VDS voltage beyond la larger VGS minus VT voltage, and thus at this point the MOSFET saturates and it has entered into the saturation region. Now this characteristic is between the the current and VDS. Now let's see the calculation how to drive the drain current. The drain current, first of all, we have to induce a channel by this equation where VGS is greater than VT, and for triode region VDS is less than VGS minus VT. Then the oxide capacitance, because of the presence of oxide layer, can be calculated by the formula of epsilon oxide divided by the thickness of the oxide. Epsilon oxide is the permittivity of the silicon order. The selection charge dq is infinitely small of the channel at dx. Suppose dq charge, a small charge over for a small distance, is minus cqs w into dx, where w is the width of the silicon oxide layer, the VGS minus Vx minus Vt. Vx is the window potential. The electric field along the channel is VDS. We already know that electric field is negative to the derivative of potential. The electric field causes dq to drift towards the drain with the velocity dx by dt. Okay. Now dx by dt is equals to mu n into E. And if you put these values, you will get this equation, the drain current equation in a triode region. For saturation region, we consider that the drain voltage is equals to the gate minus threshold voltage, and the drain current has saturated. So we have different formula for it. Mu n into cox is a transconductance process parameters. Now these are the various VGS minus VT is greater than VTS, and that means that the VDS applied is very small. Then VGS is equals to VT plus ID L by Kn dot W dot VGS. I think this formula is correct, but kindly look into it. If you find it any changes in this formula, do mention in the comments. So this is the pictorial representation. I have taken it from Google. So basically, for n-channel depletion type MOSFET, in the graph shown below, in all these four types, the p channel is in the depletion type region is the one which is operating in both positive and negative VGS. In n-channel MOSFET, for n-channel VGS is positive, the VT voltage, I must say. For depletion type n-channel VGS is negative. Okay. For enhancement type VGS is negative, and it keep on being negative for p channel, and for p channel the depletion type region is again negative. But you can see one similarity, that the p channel in enhancement as well as in depletion region, the curve finally increases for VGS, which is negative. Actually, the ID is increasing when VGS is most negative. And for N channel, the drain current is increasing when VGS is most positive. So this is the similarity. However, depletion type MOSFET works in both the region, and enhancement type works only in enhancement mode. In linear region, VDS is less than VGS minus VT. The conductance of channel in linear region is G is equals to derivative of drain current with respect to the drain voltage. Mu n COX W by L VGS minus VT. Remember this formula as it's been often asked in the gate examination. Moreover, they could tell you to give conductance of the channel with respect to VGS. Either this could be VDS or it could be VGS also. So keep that in mind and try to determine that question according to what is given in the question. Not just simply put the formula. Okay? They are very smart people. So you should be very, very careful while conducting your answer and reading the questions. The